Hello, ladies and gentlemen, and welcome to Distance Learning 7.3, Factor a Difference of Squares. All right, so a difference of squares, that's a new concept for us. That's a new idea. Difference of squares, anything, and I'm using variables here. I'm using a squared and b squared. We do know that when we say something like 3 squared, that's what we say. So that's 3 squared, and it means 3 times 3, which is 9. So saying squared is the same as saying that it's the base, the bottom number, times itself, so that there are 2 of them. That's squaring something. So this is a squared minus b squared. So this is a square, a squared. This is another square. This is b squared. And this is subtraction, which is often known as a difference. So this is a difference between 2 squares. Now, there's another reason why they call it a square, by the way, just in case you're wondering. 3 squared means 3 times 3. And if we think about multiplication in terms of area, that would be a length of 3 and a width of 3, creating a square. And 3 times 3 would be 9. So that's what gives us, and if this was an area, we'd call this centimeters and centimeters. This would be centimeters squared. And that's why we call it a square. So a difference of squares. A difference of squares is going to be whenever we have one term squared, subtract a difference, another term squared. Now let's not confuse that with a sum of squares. That's addition. So we call that a sum. There is no factoring a sum of squares. There is only factoring a difference of squares. Now, I'm going to tell you just a reality of the situation. A difference of squares, I put it inside brackets for some unknown reason, means the same thing. A difference of squares can be factored. Now remember what we said about factoring. That's when we're going to break it up into 2 multiples. It can be factored into 2 binomials. So this difference of squares can factor into these 2 binomials. Now, you may believe me at this point or you may not. And you know what? I perfectly understand that. Let's say you are sitting there and you say, Mr. White, no, there's no way this is true. That cannot be the case. Well, let's take a look. I'm going to take a minus b and a plus b, which is this. And I'm now going to apply something that we all know how to do, and that's the distributive property. So the a is going to be multiplied through to both terms in the second one. So that's a times a, which is a squared. That's a times b, which is ab, and it's positive. Now, negative b times a is negative ba, and negative b squared. Now, a couple of things we have to agree on here. A times b and b times a are the same thing. 3 times 2 is 6, and 2 times 3 is 6. It doesn't matter the order that we multiply. So this is multiplication. This is simply this, a times b minus b times a minus b squared. So there is no difference in writing it. So instead of it being ba, I can make it ab. Now look what I got here. I've got 1ab, subtract 1ab. So I've got an ab, subtract an ab. Well, that's going to leave me with no more ab's. So I'm going to be left with a squared minus b squared. Ta-da! It's like magic. This difference of squares, when we work back up through here, takes us to this factored form. And when I have this factored form, it moves forward to give me the difference of squares. Now remember what I said. There is no such thing as factoring a sum of squares. So if I have a sum of squares, a squared plus b squared, some students erroneously think, erroneously means wrong, thinks that that could be factored like that. Well, let's see if that is in fact the case. A plus b times a plus b. The distributive property, a squared plus ab. Now this is b times a, which we've already talked about. The order doesn't matter, so I'm going to write it like a times b, and b squared. Notice this time I have 1ab plus 1ab. Well, that gives us 2ab's. This is not what I started with. So no, this is an incorrect, a false statement. Not true. So there is no such thing as factoring a sum of squares. There is, in fact, factoring a difference of squares. So once again, we need to learn that this can be factored into the two multiples, the two things to be multiplied together, a minus b, a plus b. And let's not confuse the issue here. There is no difference in the order that I put these in. So the first one can come first or the second one. What's happening here is we're getting that first term going in the beginning of both of them without the square. And we're getting the second term going in the second part for both of them without the square. And one is positive and one is negative. And what that does is it gets rid of that middle term, remember? So once again, let's see, a plus b, a minus b. When we expand, we get a squared minus ab plus ab minus b squared. It's because of this plus or minus that we get this minus and plus, which allows us to take these two terms, which are the same, one's negative, one's positive, and it leaves us with the difference of squares. We're going to be doing this with numbers. This was your introduction. Let's go on to the lesson.